Hi everyone, in this video we are going to discuss two power series. We will find their radius of convergence, interval of convergence and set S. Set S is a set of all points for which the given power series is convergent. This is the first power series we have. Let me mention here. So what will I do? I will compare this power series with this standard form of power series. Cn x raised to n, here x raised to n upon n square. So Cn is a multiple of x raised to n, which is 1 by n square here. So here Cn is 1 by n square. So there you can use n, Cn, doesn't matter, value will be same. First of all, we will find the radius of convergence. We denote the radius of convergence by r and having a formula 1 by alpha, right? So alpha can be calculated in two different ways. Let me mention. The first way is alpha is equal to limit n tends to infinity supremum of mod Cn raised to 1 by n, and the second formula alpha is equal to limit n tends to infinity mod Cn plus 1 upon Cn. See, you can use n here or Cn, doesn't matter, formula will be same, right? And we will have the same final value. See, now the question is which formula we have to use to find a value of alpha, right? Generally, my suggestion is if in a power we already have n, then we go for first formula. If in a power you have n, that n and 1 by n will get cancelled to each other, right? And easily we will get an answer. Otherwise, it is better to go for the second formula. So in power, okay, in power there is no any n. So that's why I will go for the second formula. For second formula, we need to have Cn plus 1 also. Let us replace n by n plus 1. I got Cn plus 1. Then, I will use the formula of alpha, which is limit n tends to infinity mod Cn plus 1 upon Cn. Okay, so let us do. This is so much important thing. So let me keep as it is. Okay. Okay. So this is equal to limit n tends to infinity. See, there is no need to apply mod since we have squares here and those cannot be negative. So that's why I will remove mod. Cn plus 1 is 1 upon n plus 1 square upon the Cn is 1 by n square. See that n square is in denominator of denominator, so it will go to the numerator and we will have limit n tends to infinity n square upon n plus 1 bracket square, right? Now what will I do? I will to find the value of limit, I will divide numerator and denominator by n square. So let us do. So this is equal to limit n tends to infinity. I am dividing numerator by n square and denominator also by n square. So I am writing a common square here, n plus 1 by n. So this is equal to limit n tends to infinity. N square will get cancelled. If I divide separately 1 plus 1 by n whole square. So if you apply the limit, let us see what will we have 1 plus n tends to infinity, the value of 1 by n is 0. So it is 0 square. So finally we get the value 1. So that means value of alpha is 1. So let us find radius of convergence. Then radius of convergence, we denote it by r and its formula is 1 by alpha. But the value of alpha is 1 we have got. So 1 by 1, which is 1. So I got finally the radius of convergence is 1. After that we have to find the interval of convergence. So let me mention interval of convergence. It has very simple formula, minus r comma r. Our radius of convergence is 1. Let us put here minus 1 comma 1. This is interval of convergence. Now the next question is we have to find the set S. Okay, what we have to do? We have to find set S. S is a set of all real numbers for which okay, for those points the series power series is convergent. So obviously for each point of interval of convergence the power series is convergent. Simply we need to check convergence at boundary points. Boundary points, that means that point 1 and minus 1. We will discuss the convergence of power series for those points 1 and minus 1. Let us do that. Make a screenshot of it, then I will go further. So let us discuss for 1. Okay, for x is equal to 1. So the power series will be n running from 1 to infinity. I am putting x is equal to 1, 1 raised to n is 1, 1 by n square. So for x is equal to 1, we get power series like this. So it's a p series, getting na? It is a p series. It is a p series. So let me tell you what is p series, okay. So series, any series in this form, 1 by n raised to p, we call it as a p series, If p is greater than 1, the series is convergent, and if p is less than or equal to 1, we say the series is divergent, okay. So this result we have. So it is similar to that one. So it's a p series with what is the value of p? 2, obviously, power is 2, and which is greater than 1. Our result says if we have a p series with p greater than 1, it is a convergent series. Therefore, it is convergent series. That means for x is equal to 1, we get a convergent series. Let us check for x is equal to minus 1. For x is equal to minus 1, okay. So summation n running from 1 to infinity. At a place of x, I am putting minus 1. So minus 1 raised to n upon n square. Okay, so now we have to check whether it is convergent or not. So what will I do? I will do a very simple thing. I will apply mod to it. Okay, so let us see what will happen. Then I am applying mod n running from 1 to infinity. I am taking mod minus 1 raised to n upon n square. So this is equal to, summation I should write, n running from 1 to infinity. If you take mod, definitely it will give a positive real number. So minus 1 raised to n, by applying mod we will have simply 1, so n square. That means again we get a same series. So it's a p series again, and we can say it is convergent. Therefore, summation 1 by n square is convergent. The reason is same. What is the reason? Since it is a p series with p is equal to 2, which is greater than 1, so it is convergent. But see, this is nothing but mod of this one, no? So I can say n running from 1 to infinity mod. That means we say it is absolutely convergent, is absolutely convergent. Why we are saying it is absolutely convergent? Since by applying mod also we get it's a convergent series. So that's why we say it is absolutely convergent series. We are familiar with one result. Every absolutely convergent series is convergent. So therefore we can say implies n running from 1 to infinity minus 1 raised to n upon n square is convergent. The reason is every absolutely convergent series is convergent. Okay, so that's why we say it is a convergent series. So let me tell you once again. So this series we had got, which is convergent since it is a p series with p greater than 2, same reason I can give. This series is convergent, it's therefore we can say this is also convergent since both are equal. This is convergent, but it has a mod, so that's why in the same thing we can write in this way, it is absolutely convergent. Every absolutely convergent series is convergent, so that's why it is convergent. So what I want to say, if I take x is equal to 1, then also it is convergent, and if I take x is equal to minus 1, then also it is convergent. That means at both boundary points we get a convergent series. So just make a screenshot of it, then I will write further next step. So therefore our set S means what? All real numbers for which the series is convergent. The interval of convergence is minus 1 comma 1. Okay, for those points series is definitely convergent. As well as we proved for 1 also it is convergent, and for minus 1 also it is convergent. So that's why the total set can be expressed in this way, close interval minus 1 comma 1. So this is required S. Okay, make a screenshot of it, then I will go for the next example. So this is second power series we have. Okay, summation minus 1 raised to n, x raised to n upon n. So let us write here first Cn. So what will I do? I will compare this power series with a standard power series. Multiple of x raised to n is Cn here, and multiple of x raised to n is minus 1 raised to n upon n. So this is our Cn, right? See, we have to find first radius of convergence. Radius of convergence having formula 1 by alpha. Alpha can be calculated in two different ways. So we have to decide first which formula we have to use, right? My suggestion is, if you have n in a power, then go for the first formula, otherwise go for the second formula. See, in a power we have n, but it's a minus 1 raised to n, having just values plus 1 or minus 1. In denominator there is no any power. So it is better to go for the second formula. Okay. In second formula we need to have Cn plus 1. Let us find Cn plus 1. It's very simple thing. Simply replace n by n plus 1. Minus 1 raised to n plus 1, and in denominator also I can do. So therefore alpha limit n tends to infinity, we have mod Cn plus 1 upon Cn. So let us put values. Limit n tends to infinity, Cn plus 1 is this one. Okay, so minus 1 raised to n plus 1 upon n plus 1, right? And what is our Cn? Cn is this one, minus 1 raised to n upon n. So let us write the remaining part here. So which is equal to limit n tends to infinity. Okay. See, because of mod, that minus 1 raised to n plus 1 will be 1 only. Mod will absorb minus sign and it will return simply positive values. So we will have 1 upon n plus 1, and in denominator we have 1 by n. Because of mod, I have removed that minus 1 raised to n and minus 1 raised to n plus 1. This n is in denominator of denominator, it will go to the numerator. So we will have limit n tends to infinity, n upon n plus 1. So there is very simple technique to find the value of limit. Let us divide numerator and denominator by n. Since the highest power of n is 1, so I am dividing numerator by n and denominator also by n. So limit n tends to infinity, n cancel. In denominator I will divide separately. So 1 plus 1 by n. If we apply the limit, see 1 plus, if you apply the limit n tends to infinity, 1 by n is 0 and finally its value is 1. Okay, so the value of alpha is 1. Now I will go for the radius of convergence. So therefore radius of convergence we denote it by r and having formula 1 by alpha. We got alpha 1, so 1 by 1 which is 1. So finally I got the radius of convergence which is 1. Let us go for the next point, interval of convergence. Interval of convergence. Very simple formula, minus r comma r. Let us put r1 minus 1 comma 1. So this is the interval of convergence. After that we have to find set S. S is a collection of all real numbers for which the power series is convergent. So obviously for interval of convergence also having a same condition, simply we need to check at boundary points minus 1 and 1. So let us do that. Just make a screenshot of it, then I will go further. So first of all I will discuss the convergence of this power series for x is equal to 1. Let us see, if I put x is equal to 1, we will have summation n running from 1 to infinity minus 1 raised to n. 1 raised to n is 1, so 1 by n. So this series I got. Actually it's a alternating series. Alternating series means if I put 1 here, minus 1 by 1, plus if I put 2 here, it will be plus 1, 2, minus 1 by 3, plus 1 by 4 and so on. So see, and so on. So that means having alternating minus plus signs, so that's why we call it as a alternating series. See, there is one standard result, Leibniz rule we call it as. If you have alternating series, we can apply Leibniz rule, and using Leibniz rule we can prove this is a convergent series. So let me simply mention by Leibniz rule of alternating series, by Leibniz rule of alternating series, summation n running from 1 to infinity minus 1 raised to n upon n is convergent. So it's a convergent series. That means for x is equal to 1, we get a power series is convergent. Let us discuss for second boundary point, minus 1. Okay. So let me do the remaining part here. Just I will start the next part here. So for x is equal to minus 1. So let us see what will happen if I put x is equal to minus 1. Summation minus 1 raised to n, x is also minus 1. So minus 1 raised to n upon n running from 1 to infinity. So this is equal to summation n running from 1 to infinity minus 1 raised to n, that means 2n, since base is same, divided by n. But you know that if power is even, its value will be 1. So that is summation n running from 1 to infinity, 1 by n. Getting my point? See, in power we have 2, no? So it's a even number. So that's why its value will be plus 1. So it's 1 by n. So it's a P series. I have already told you P series means what? P series means 1 upon n raised to P. We call it as a P series. Here it is a P series with P is equal to 1. This is P series with P is equal to 1. I have already told you, when we say the P series is convergent, if P is greater than 1. Here we get P is equal to 1, so that's why it is not convergent. So therefore, this series is not convergent. Okay, so therefore this series is not convergent. Getting the point? This series is not convergent. That means for x is equal to 1, we get the series is convergent, and for x is equal to minus 1, we are not getting the series is convergent. So therefore, let me mention here, therefore set S, then S is equal to, obviously the that interval of convergence minus 1 comma 1 union. This point also I will add there, since for 1 also we are getting a convergence series, union singleton 1. That means we will have a set like this, open at minus 1 and close at 1. So this is required set S. In this way we have completed this example. Make a screenshot of it, then we will stop. Thank you. See you.